Good evening, friends. This is Manish Khandelwal. I am a mechanical engineer, and the details of my experience are mentioned at the bottom of this slide. Last week, I made a presentation on hydraulic system. Few of my friends wanted to have a presentation on pneumatic system also. So through this presentation, I have tried to make an attempt to convey you few important things in a pneumatic system. So first let me tell you what all I am going to present in the pneumatic system. First is what are the components of a pneumatic system. Then second is how do we generate compressed air. Third is how do we prepare the compressed air. Then fourth is what is the working of a pneumatic system. Then it will be the difference between a hydraulic system and a pneumatic system. And last will be the application of a pneumatic system. The components of a pneumatic system can be divided into three major parts. 1. Generation of compressed air. Second, conditioning of the compressed air we have produced. And third, how do we use this conditioned compressed air. I have used three different colored bullets to show these three different stages. One color is for generation, second color is for the conditioning, and third is for usage. Though the compressors are of two types, one is positive displacement compressors and second dynamic compressors. I have referred here reciprocating compressors and screw compressors, and both these two compressors are positive displacement compressors. So compressed air is generated by a compressor taking in atmospheric air. The impurities in the compressed air are removed by a filter. Its pressure is controlled by a regulator, and the compressed air is then lubricated before getting stored into a air storage tank. The stored air as required is taken into the system and given desired direction by a directional control valve. This air is then used by tools, machines, etc. I made my presentation briefly explaining the above three stages of the pneumatic system. As I mentioned in my previous slide, I am referring two types of air compressors in this presentation. One is reciprocating air compressors and second is screw type air compressor. You can see a picture of a small reciprocating compressor where the air receiving tank is mounted on the compressor. The reciprocating air compressor is designed to compress the air. The basic components of reciprocating compressors are cylinder, which is shown here with the blue lines, piston in green color, and this slides up and down in the cylinder, the crankshaft, which is connected directly with the motor, and the connecting rod, which is connected with crankshaft at one end and the piston at the other end. The piston moves up and down inside the cylinder. When the motor starts, the crankshaft connected to the motor starts revolving. The design of the crankshaft is such that it converts the rotating motion into reciprocating motion. The connecting rod and the piston attached to it start the reciprocating motion inside the cylinder. During the downward stroke, which is also called suction stroke, the pressure inside the cylinder reduces. the atmospheric pressure becomes higher. This results in atmospheric pressure coming in the cylinder via intake valve. As the piston moves up, the air starts getting compressed. This stroke is also known as compression stroke. Before the compression stroke is completed, the discharge valve opens and the compressed air is released from the cylinder. And then the suction stroke starts. So this is the cycle which keeps on repeating. The reciprocating compressors can be single stage or multiple stage depending upon the requirement. The compressor works on a same principle in all types of reciprocating air compressors. The air is compressed passing through multiple cylinders in a multi-stage compressor. For example, in two-stage reciprocating compressor, the first cylinder compresses to an intermediate pressure which is then passed through an intercooler which removes some heat. The air is then becomes input to the second cylinder where it is compressed to the final desired pressure. We can achieve higher pressure from multiple stage reciprocating compressor. The temperature of the compressed air is better managed in multiple stage compressor as the intercoolers are provided between the stages. For example, the desired pressure is 8 kg and there is a multiple stage compressor. So maybe in the first stage the compressed air pressure is 4 or 5 kg only. It is then passed through intercooler which removes the heat of the compressed air. Then it goes into the second stage where it is compressed to 8 kg, the desired pressure. So the temperature is also reduced, the pressure also better managed. Whereas in a single stage compressor, we will have to compress the air from atmospheric pressure to 8 kgs. Second type of air compressors we are discussing is screw compressor. In a screw compressor, two interlocking rotors rotate in a housing in opposite direction as can be seen from this picture. These rotors are called male and female screws. The extended portion of the male rotor moves in the female rotor cavity. So this extended portion and cavity are called lobe and flute also. The air is compressed between these two screws from inlet to outlet as the volume of the cavity between these screws reduces. So blue color is shown for the air inlet and red color is the outlet. The compressed air is then forced through the outlet port. These screw air compressors are highly efficient and are preferred in industries where the required volume of compressed air is more. The screw compressors are relatively quiet and need lesser maintenance. Once the air is released from the compressor, it needs conditioning, or we need to prepare the compressed air which is suitable for the actuators. So the compressed air after it is released from the compressor is stored in a air receiving tank. A typical picture of air compressor receiving tank is shown here. A lot of moisture from the compressed air is separated in this receiving tank. This tank is also having a safety valve. If the pressure of the compressed air inside the tank crosses the set value, then the safety valve operates. It is spring loaded. The extra pressure is released from this valve. The moisture in the tank is collected at the bottom. You can see the valve here. In a manual valve, we need to operate this valve to take out the moisture collected in the tank. But now most of the industries are installing auto drain valve, where you set the time and the moisture is taken out from this tank at the fixed frequency. A significant amount of heat is generated when we are compressing the air or when we are generating the compressed air. As we have seen before also, an intercooler is installed if the compressor is multi-staged. So the compressed air generated in the first stage passes through the intercooler, which removes some of its heat, and then it is fed into the second compressor. After that, it is going into the aftercooler. The aftercooler is sort of heat exchanger where the cold water is running inside the tube and the hot air is coming. It is hitting the cool tubes and cold air is moving out. The cold air becomes hot and it is taken out. It's a typical heat exchanger. Of course, in a single stage compressor, we don't have any intercooler because there is only one stage. The taking out of the heat from the air compressor is extremely important to avoid damages to the equipments in the pneumatic circuit. Next equipment used to condition the compressed air is an air dryer. You can see a typical diagram of an air dryer. It has got a compressor, condenser, an evaporator and a trap. These are the four major components of an air dryer. The working medium of an air dryer is freon gas generally. The air dryer removes both heat and moisture from the compressed air. The hot freon vapors enter into the compressor. The temperature and the pressure of the freon vapors increase after the compression process. Hot freon vapors then enter into the condenser coils. These are the condenser coils. An exhaust fan takes out the heat from the freon vapors. The freon vapors become cool and a large quantity of freon vapors get converted into high pressure freon liquid, which then enter into the evaporator. This is an evaporator via capillary tube. This capillary tube further reduces the temperature. In evaporator, freon liquid takes a large amount of heat from the compressed air. So what happens? The compressed air becomes cool. The freon liquid gets converted into the freon vapors for the next cycle. During the process, a large amount of moisture is also liberated by the compressed air, which is collected into the trap, and the cool air is taken out for further use. The last equipment I am presenting for air preparation is FRL unit. It stands for filter, regulator and lubricator. This is a very important unit in a pneumatic system. It helps in regulate and maintain the compressed air supply. In most of the cases, the filter and regulator are combined into a single unit. As can be seen from this picture, the regulator and the filter are combined into a single unit and the lubricating unit is separate. The compressed air enters into the filter from the sides. The filter element arrests the contaminants in the compressed air. It also arrests the residual moisture which is collected at the bottom. The regulator at the top regulates the air pressure we need. Suppose the compressor is producing the compressed air at pressure X, but we need pressure X minus. So we can regulate the pressure here by rotating this knob. Now this regulated and cleaned air is moving further. Some of the air goes into the lubricating unit where it makes this lubricating oil go from this flexible pipe to the top here, and then the lubricating oil will start dropping down drop by drop here. This lubricates the compressed air, and this lubricated compressed air is then used by the actuators. This lubrication is very important because in hydraulic system we are using hydraulic oil as the working medium, but here the working is done by compressed air. So we need to lubricate it so that our pneumatic system is lubricated properly and the life of the pneumatic system is more. The cleaning of the filter unit can easily be done. You can pull down this switch, rotate it, this metallic portion can be removed. Then you have a glass portion. This glass portion, by removing, you can remove the glass. If you want to clean the filter, you can clean the filter. If you want to change the filter, you can change the filter then. Similarly, if you want to top up the lubricating oil, you can remove it and top up the oil. Friends, in many industry I have seen that this particular unit is ignored. Sometimes this unit is even bypassed. People are not understanding the importance of this unit. So we need to maintain this unit to the best. Now the compressed air is generated and conditioned and ready to be used in a pneumatic circuit. Just to recall, this is a air compressor, reciprocating type. This is screw type. The compressed air is coming out. It is going into the aftercooler, which removes its heat. Then it is going to the air dryer, which removes the moisture and the heat. Then it is collected into the air receiving tank. Air receiving tank is having a safety valve. If the pressure inside the air receiving tank increases, the safety valve operates and releases the excess pressure. We can see the pressure in this pressure gauge. We have a drain cock here. So the moisture which is getting collected at the bottom can be removed from this drain cock. Auto drain system is also available, which normally people are attaching to air receiving tank. This is single stage compressor. If we are having multi-stage compressor, then intercooler will also come between the two stages. Now we can see the piston of a pneumatic cylinder can be attached to this pneumatic circuit. Now how will it act? If you recall, in hydraulic system we had directional control valve. Here also we have directional control valve. So air from the air receiving tank is pulled. If it is not being used, then this port will work. The air will come from here and go out. For the forward motion, the air will travel from this port it will enter from the bottom. It will push the piston up. Now this air between the cylinder and the piston shall move out from this port and will get exhausted here. In the reverse cycle, the air will enter from this port. It will go to the top, push the piston down, and the air between the piston and the cylinder shall move out from this and it will be exhausted. So hope this is clear. This is very simple and very close to what we have learned in hydraulic circuit. Let's understand few differences between hydraulic and pneumatic system. In pneumatic system, the working medium is compressed air, whereas in hydraulic system, the working medium is hydraulic oil. In pneumatic system, the air is compressible and inflammable, whereas the hydraulic oil is incompressible and flammable, if you can recall the Pascal law. In pneumatic system, force developed by the system is less. In hydraulic system, the force developed is high. The air viscosity is low, hence the system is very fast, so air travels fast, whereas the oil is more viscous, hence the system is slow. The separate lubrication system is required. If we recall in the FRL unit, we studied it. In hydraulic system, we do not need any separate lubrication system because we are using the hydraulic oil as the working medium. Pneumatic system is low maintenance system, whereas the hydraulic system is having a higher maintenance cost. In pneumatic system, the working medium is produced in-house. We intake the atmospheric air and do the compression, whereas in hydraulic system we need to purchase the hydraulic oil. The application of pneumatic systems are many. We can use it in a lot of hand tools for drilling, fastening, etc. We can use it for paint spraying also. We can use it for drilling the concrete and the road also. And of course we use it for the pneumatic presses. So this is all in this session. If you like the presentation, please subscribe my channel. And if you have any comments to make, please forward so that I can make my future presentations better. Thank you very much in advance.